Hello everyone, this is James Shore with another test-driven development video. I'm recording this on February 26, 2012, and picking up pretty much where I left off in the last episode, which was looking at a bug that had crept in due to some refactorings I was doing in the user-entered dollars. The specific issue was that I had made a refactoring that broke a test to see that dealt with when this value got too large. Now I fixed that. It is working now. But I've only fixed the bug. I've written the test and fixed the bug. And now I think what needs to happen is I really need to figure out what went wrong with my thought process. Now, I don't want to overthink this. This is just one defect that I found. But I want to see if there's anything about the way I approached this problem that really made the bug more likely to appear. So if we look at what happened here in user-entered dollars, let's go ahead and pull that up. So if we look at what happened inside of user-entered dollars, it was the actual error was right here. We said dollars.create. We had new valid dollars rather than dollars.create. And the issue there with the design, I think, well, I mean, the way that got in is that I did an automated refactoring, converting create into a new method. I wonder if there's something about the design of this that made that a little more likely. If we go into valid dollars, I've since moved that create method into dollars, but the issue is right here, public valid dollars. I just wonder if that should be private or if it should throw an exception, a checked exception that would make it easier to tell from a design perspective what was going on. And, you know, as I look at it, this method is really not intended to be used anywhere else. The problem is that if I take this out, if I make this non-public, what happens is that everything breaks because I've got so many tests that rely on the creation of dollars. Now, maybe what I should be doing is just having those classes use dollars.create instead of saying new valid dollars. But from a test perspective, I think it really does make a lot of sense to say new valid dollars. The problem with that is that I think that makes the design a little more error prone. It's easier in that case to create a valid dollars that will throw an exception. You know, I'm really not sure how to deal with this. There's two competing tensions. One, on the one hand, I want to make sure that the design can't be misused. I don't want you to be able to create a valid dollars that can actually have an invalid result coming out. On the other hand, I like the clarity of new valid dollars that doing this in the test creates. And I also don't like the unclarity of dollars.create for a test. I want to say, yes, I'm dealing with valid dollars, and no, I'm dealing with valid dollars. So I think for now, I'm going to go ahead and leave it as it is. I'm not sure what the right answer is here, and I don't want to overthink it. Sometimes it's tempting when you find a bug, if you're in an environment where you're saying bugs should be really rare, it's tempting to take each bug and turn it into a huge amount of process, which is actually wasteful. We don't need to turn every single defect into a huge amount of process. At the same time, we do want to make sure we're not making common mistakes. So I think I am going to go ahead and leave this public for now. Actually, maybe what I can do is rename this variable to be a range limited amount. That will, yeah, that should be a good compromise. That should make the design a little more clear in that when somebody, namely me, tries to use that method or that constructor and I look at the list of parameters, I'll see that it says range limited amount, and hopefully that will inspire me to look at valid dollars test. And the first thing I'll see there is cannot construct dollars out of valid range. That is my documentation right there. So yeah, I'm liking that. And Yeah. Yeah, I think that will do. Now, the whole reason for this issue in the first place was that I didn't want to allow dollars to be constructed too large. And the reason for that was because that there was an overflow and underflow problem that would occur with a double. If you get double to be up to its maximum value and then add 1 to it, it doesn't throw an exception, nothing happens, it just ends up being too small. Or I actually don't remember exactly what happens, but I think it overflows and then wraps around or something like that. So I instituted this range limit in order to correct that. But a true fix here would be to change the underlying data type to be something like big decimal or whatever the Java equivalent is. I think it's big decimal, rather than using a double. But just that feels like too much complexity. I think this change here, this clarifies the design, allows me to keep things simple, but still speaks to me or another person who's using this code in the future about what's going on. Okay, so if you remember, the process for what you do when you find a defect is to first write a test, reproduce the bug, write a test, fix the bug, fix the design to make that kind of bug less likely in the future, and then to do root cause analysis on why that bug crept in the first place. So the question is why, and my favorite technique for root cause analysis is the 5 whys. So why did we get a regression? Well, because we were using an automated refactoring, that automatic refactoring substituted in a new method in place of the create that had the protection on it. Why did it do that? Well, we told it to. And why did we tell it to? Well, because we were intentionally taking out the create method. Why didn't we see that taking out the create method would work? I don't know. We actually did see a test and changed the test and thus the behavior of the application, but didn't make the connection. I didn't make the connection that that test would cause this problem. Why didn't I make that connection? Well, it might have been, I don't remember exactly. It might have been towards the end of the episode, and I'm always a little rushed at the end of the episode trying to get things done. So it could have just been taking things too quickly. This whole set of code definitely has taken longer than I expected. I didn't think I would have so much trouble doing user under $, so I might have been rushing there. Another thing could be that I was using automated refactorings, and I'm used to, when I first started doing refactorings, I would do them manually, and that would require me to look at each change as I made it, although I'd still go through it pretty quickly. Also, I do tend to just trust my tests and be a little bit sloppy. So ultimately, I think what happened here was that I trusted the tests and at the same time changed the test. I trusted the test to tell me when I was making a mistake, and I was changing the test. So what that tells me is that if I'm going to change the tests, I think I need to be a little more careful about what that means. So let's see. If we go down to our root cause checklist, here's another one. When changing a test, you could break the expected behavior of the application. Therefore, go a little slower when taking out or changing expectations of tests. That's my best shot. Maybe you guys can come up with some better ideas in the comments. That's what I think happened. I don't want to get, as I said before, I don't want to get too twisted up around this. It's just one defect. It's not a repeated pattern. It's not until I see a pattern behavior that I want to make dramatic changes. The biggest, and this is not a dramatic change. None of the changes I've made so far are dramatic changes. One thing that is a problem with this checklist is I don't look at it before I check in. So and I don't see a way of enforcing this automatically. If this continues to be a problem, it might be worth investing some more time in to fix more directly. But let's go ahead and consider that good. So I'm going to go back to our top of our list. We fixed this bug. Thank you, Esco, for pointing that out. Esco also suggested a file format for our save file, which looks really promising. And then we've got some other things that we haven't gotten to yet. So I think it's time to move on. I think we're ready to go back to the save file. And in the save file, here it is. We're going to need to be able to start saving. And we're also going to, we had a test to make sure that the save file wrote the file contents. Now we're going to need, we'll want to finish this up. And what we'll want to do is we'll want to say save writes file contents, but I think we're also going to want to say we're going to want to test that something like save writes even original data regardless of validity or something like that. So that's what we're going to do next. But in order to make that work, we're not quite done with user entered dollars. We have to go back here and have some way of getting the original data out so we can write our test. And I'm going to do that with a little method called get original or get user entered value. It's either user entered data or user entered value. I'm not sure which. And let's say that that's obviously just going to return us exactly what we put in the first place. And that will have to be assert equals, not assert true. And that's not working because it doesn't exist. That's going to return a string. Let's put this up by toString. That's going to fail because it hasn't been implemented. Expected that was null. And now we can finally get rid of that warning that's been hanging around. Get return user text. Simple, simple. Okay. I don't really like this method name. I think get user text is actually a better name. User entered dollars, user text. Yeah, I think that works. Okay, so that should still pass. All right, now we can get rid of everything except for our save file test and our save file. We've got just a minute left. I don't think that's going to be enough time for us to finish this off. But let's see what we can do. Let's go ahead and bring this back. And now we can say new user entered dollars. And we'll expect it to just write out exactly what we put in. This, of course, will have to be a string. And let's see if that works. It shouldn't work. Nope. And now here we'll take a user entered dollars and starting balance dot get user text. And it should be just that simple. No. What is wrong here? Oh, this doesn't work. Okay, well, we're going to have to come back to that next episode. Thanks very much for watching, everybody. I will catch you next time.